Okay, in this video we're talking about basics to triangles. So we have some vocab and some relationships that we're going to discuss in order to better understand triangles. So first up we have classified triangles by their angles. So we have, just like we talked about angles, we have acute, obtuse, and right. These are our three classifications for triangles by their angles. So acute triangles are all angles are less than 90 degrees, and the keyword there is all angles. So I like to use my pencil and make sure to mark acute, like so. Okay, the next guy is obtuse, and the key thing for obtuse is that only one angle is greater than 90 but less than 180. Okay, and that's because if I have two angles that are greater than 90, well then that doesn't meet the rules for a triangle where the interior angles or the angles inside the triangle have to add up to 180. Because at the smallest obtuse angle, which would be 91, plus 91, I'm at 182 and I haven't even factored in the third angle. Lastly, we have one angle, we have our right triangle, which is one angle is a right angle. Again, the key thing here is 1, and we're looking for the right angle measuring at 90. And for the same reason as obtuse, we can only have 1 because if I have 90 plus 90, that equals 180, and I still haven't factored in the third angle. In a triangle, all angles in a triangle have to add up to 180. So I would be too big. So it's important to realize that with obtuse and right, I can only have one of the angles that are classified. So we can only have one obtuse or one right in those two triangles. We can also classify triangles by their sides. We have three vocabulary words here as well. We have scalene, isosceles, and equilateral. Starting with scalene, scalene means that no, that's the key word, sides or angles are congruent. So we're bringing back congruent, which means same, for those of you that forgot. Okay. We also have isosceles. Isosceles, we are utilizing our tick marks and our arch marks in order to show congruency. But more importantly, an isosceles has two sides and two angles that are congruent. Okay, so it's important that we know that isosceles is 2. And then lastly, we have equilateral or equiangular. No, it's not on here, but equilateral. And the big thing is this equal, and it means that all sides and all angles are congruent. So equilateral means everything is equal, which means all of our angles are going to be 60 and acute. And again, we're using these tick marks to show that all sides are congruent. So in the examples below, if we notice I have two tick marks and the angles opposite of them are also congruent. I notice that I have 1, 2, 3 acute angles, so this guy would be an acute isosceles. I always struggle spelling isosceles. Next up, we have 3 angles that are all congruent, and one of them 60. So we saw that that means that this is a acute, because 60 degrees is acute, equilateral. Now we see that we have a 90-degree angle because of our box, but we have two sides that are congruent. So this is a right triangle because of the box that tells us 90 degrees, but also isosceles. Okay. So that's just some key vocab and some ways to identify triangles either by their angles or their sides. Now next up on page 2, we're talking about a relationship called the triangle inequality theorem, which says the sum of the lengths of any two sides must be greater than the length of the third side. Okay? So if I take any two sides of a triangle, they must be greater than the length of the third side. And the best way to do this is to really pick the two sides that are the smallest and see if it's bigger than the biggest side. Because if you do that, then you are guaranteed that all other pairings, whether it be the small and the big, greater than the other small, all other pairings will meet this requirement of two sides added together being greater than the third side. So we see here it tells us that AC, so if I were to say this guy, AC is X, AB, Y, is greater than Z, then I can say that X plus Y is greater than Z. And if that's true, then this is in fact a triangle. So let's do a couple examples and find out. So my smallest side in this group is 8 and 10. So if I do 8 plus 10, is that greater than 12? Well, we find out that 18 is in fact greater than 12. For this guy, though, we have 1 and 2 as the small side. So 1 plus 2, is that greater than 3? Well, 3 is not greater than 3. So this one is no, and this one was yes. Okay? Here we have 4 and 5 as my two small sides. So 4 plus 5, is that greater than 10? Well, 9 is not greater than 10, so that is also no. Here they tried to trick us and have 14 and 15 next to each other, but the two smallest sides are actually 11 and 14. So if I do 11 plus 14, is that greater than 15? Well, 25 is greater than 15, so this guy is yes. So make sure you're paying attention to which numbers are the smallest and making it greater than the bigger. Remember, it has to be greater than. It cannot be equal like we had in this example. Cannot be equal. Has to be greater than. Okay? Now we have our angle-side relationships. So the big thing with these is that the largest angle matches to the opposite of the longest side. And so what that means is angle A is this angle, and I'm going to highlight it, but it goes with this side. Notice how it's opposite of the angle. Okay? We're looking for the opposite side to match the angle. Okay? And we can continue to do that. We have B now. We have B, which means that if we were to go opposite side, this would be the side that it matches, which is AC or CA. And then we have angle C. And if we go across the opposite, we have that side, which is AB. So if you see the pattern, whatever angle you choose, the two letters that you didn't choose are the side that go with it. So notice we have angle A, and it goes with side BC. Notice the side doesn't have an A in it. Okay, that's an easy way to remember. So now down here it says list the sides from greatest to least. From least to greatest. It's important that we read and understand. Okay, so least to greatest. Well, if I take my pin here, 40 is the smallest angle, and if I go across opposite, that was angle A, so side BC, segment BC, will be the smallest. Then we can continue and we can say, okay, 50 was the next smallest, which means that's angle B, so side AC would be the next one. And then last but not least, we have 60, which is our greatest side, which was angle C. So we have segment AB as our largest side. Okay, we can repeat that again down here. So we have a 30, a 90, and we need to know that angles in a triangle add up to 180. So if I do 180 minus 30 minus 90, I get 60 degrees. So that angle there is 60 degrees. So that tells me that my 30 here is my smallest angle, and therefore EF will be the smallest side. 60 is my next smallest angle, which is angle F, which means side DE is the next smallest. And last but not least, my 90 degree is angle E, which means that side DF is my largest side. And when we flip the page here, we have the same thing, except now it's vice versa. Now I'm giving you the side, and I'm telling you that the longest side matches the opposite of, meaning largest angle. So, for example, BC, which is this side, would match angle A. Okay? Just like CA would match angle B. Okay? And lastly, we have AB, which across from it is angle C. Okay? And so we can do least to greatest again. So in example 3 here, our smallest side is AC, which means that our smallest angle is going to be angle B. We then see that 4.8 is our next smallest side, which means the angle across from it is angle A, which makes it the next smallest angle. And last but not least, we have side C, which is our greatest side, or sorry, side AB, which is our greatest side, and that goes with angle C. Down below, we can repeat this again. Side DE is the smallest side, so angle F would be our greatest or smallest angle. Then we have side DF is the next smallest, so angle E would be the next smallest angle. And lastly, we have side EF, which tells us that angle D is the greatest angle. Okay? This is everything for introduction to triangle basics. The next couple pages are going to show us a couple of equations.